Hey functions. Okay, so this was the warm-up that we started with today. So go ahead and find the domain for all of these functions, these rational functions. Make sure when you're doing domain, you're thinking about just what are the possible x values, and then where will this function be undefined. So go ahead and hit pause and complete those. Okay, so the domain for the first one is all real numbers, and I was going to show you what I mean by all real numbers. So when we go into, if I were to graph that first function, it's a line, and a line has a domain of negative infinity to infinity. So it's going to be all real numbers. So that's why that one is that way. For g of x, we do have an x in the denominator, so this is going to be a hyperbola. So we are going to have to set the denominator not equal to 0, because remember, we want to find out what is the value of x that's going to make that 0, because that's where it's become undefined at that function, or in this function. And so it's going to be all real numbers such that x is not equal to -2. Something else that we learned yesterday was that rational expressions always have a domain of all real numbers, or from negative infinity to infinity, but some are going to have some domain restrictions where it can't equal that. So x is not equal to -2 here. For this one, I needed to factor the denominator and then set that not equal to 0. So I factored it here as a difference of squares. I didn't worry about the numerator, and so I got that the domain was all real numbers, such that x is not equal to -3 or +3. All right, we are going to learn how to write the rational expression in its lowest terms, or the simplified version. So we have something called the fundamental property of rational expressions that says that if we write if we take this example and we write it in its factors, so we do it for this particular one, it's a GCF, so we wrote it in its factors. Then if we have something that's exactly the same on the top and the bottom, so this turns into a 1, then we could say that this simplifies to 3 over 5, and the expression will be undefined for where x is not equal to 4. So meaning we can't have x equal to +4, right? That'll make it, that's a domain thing. So that also, this is the same thing here. This is what it's saying. If we can get it written in factors that are the same factors, and we get the same on the top and the bottom, then we can say that it simplifies to a over b. So I do want you to write this down. I would like you to write down that when you are writing rational expressions in its lowest terms, the first step is to factor. This is where I start saying, when in doubt, factor it out. You need to factor. You're going to factor, and you're going to factor, and you're going to factor. And then you're going to find the same thing that's on the top and the bottom, make a big 1, and we're going to use that. So we're going to start off with some examples. So I'm going to write these. So I can rewrite A. Let's see if I can do it. So A would be 2 times A, and I could write 4 as 2 times 2 times B, and then I have a 2 and a 2, so 2 over 2 is equal to 1, right? 2 over 2 is 1, so that's a 1, so then that would equal 1 times, or 1 over 1 if we wanted, like 1 over 1. Okay, so we end up with 1 over 1, because this turns into a 1. So 1 over 1 times A over 2 times B. So 1 over 1 simplifies to just 1. And we can say 1 times A is A, and 1 times 2 over B is 2. 2 times B is 2B. So that simplifies to A over 2B. We're going to do the same thing here. I'm going to write the 9 in factors, my prime factors, which would be 3. So 3 times 3. Then the a plus b is its own factor. It's in parentheses, so it's its own factor. Then I'm going to do the 27, which would be 3 times 3 times 3 times a. So it's something that's the same on the top and the bottom. This is the same. It's exactly the same. This is exactly the same. So then I end up with 1 over 1 times 1 over 1. This a and this a cannot be broken up. And the reason why that is, so I'm going to show you an example that I always show students. So 4 times 2 over 2 would be 8 over 2, which is just 4. Or I could have seen that these 2 over 2 are 1, and I would just get 4, right? But if I do 4 plus 2 over 2, I can't just do that because 4 plus 2 is 6, divided by 2, which is 3. So that's why we can't, when we have a plus or a minus, and this is in parentheses saying that this has to stay together, then I cannot break it up. So then I end up with times this is times not equals, times A plus B over 3 times A. So then my final answer, my fully simplified answer of all of this would be 1 times A plus B is A plus B over 3A. Okay, so the top here is all in its factor. A plus B is its own factor, because it's in parentheses. X minus 2 is its own factor, and then R is all by itself. So the numerator is going to stay, it's already factored, so we're going to have A plus B, and we have X minus 2, then times R, all over R times the X minus 2. So then we need to find the same thing on the top and the bottom. Well, we have an R here and an R here, so that turns into a 1. And we have an X minus 2 and an X minus 2. So that whole thing, because they're exactly the same, turns into a 1. So we end up with A plus B over R. And that would be our final answer. So we're going to do a little bit harder one. So the first thing that we would want to do is we're going to want to factor both the numerator and the denominator. So when we factor the numerator, so we need to find the factors of negative 3 that add up to 2. And that's going to be positive 3 and negative 1. And then we need to find the factors of positive 2 that add up to negative 3, which would be negative 1 and negative 2. And so then we have the numerator factored out and the denominator factored out. So then we have to find the same thing that's exactly the top on the bottom. And we end up with y plus 3 over y minus 2 times 1, which just gives us y plus 3 over y minus 2. The next thing that we have to do is see if b will factor any further. Well, y squared, I guess we could write it as y times y plus 4, but that doesn't really help us. So since the denominator cannot be factored any further, this expression cannot be simplified any further, and this is already in its lowest term. So you wouldn't be able to do anything else. All right. So we talked about the quotient of opposites. So in general, if the numerator and the denominator of a rational expression are opposites, then the expressions are equal to negative 1. So if we have q minus 7 over 7 minus q, then that's going to equal negative 1. And if we have negative 5a plus 2b over 5a minus 2b, it's also going to equal negative 1. Notice that the numerator and the denominator in each expression are exactly opposite. So if we had r minus 2 over r plus 2, the numerator and denominator are not exact opposites. So that means everything has to be the exact opposite. And then it's going to equal negative 1. So this is going to come up in the homework. You're going to do this. So one of the things that you can do, I'm going to prove to you that r minus 1 and 1 minus r is negative 1. So how I'm going to do that is I'm going to factor out a negative 1 in the denominator. When I do that, if I said negative 1 times r, that equals negative r, and negative 1 times negative 1 is positive 1. So this is the same thing. These are equivalent expressions. But now I have something the same on the top and the bottom, which gives me 1 over negative 1, which is equal to negative 1. The same could be true for b. So I could get p over 2, but I could factor out a negative 1 out of the p minus p squared. If I do that, then I end up with negative 1 times p squared minus 4. Now that's a difference of squares, and I can factor that. Now I have the same on the top and the bottom, so then I end up with 1 over negative 1 times p plus 2. We never want to have a negative in the denominator, so I am going to put negative 1 over p plus 2. Okay, so that was the last example that I covered today. If you have any questions, please let me know in the morning or the next day or whenever you come back to school. I hope that you have a great night. Thanks.